to my YouTube channel. In today's video lesson, I'm going to be doing mathematics, and we are going to take the second phase of our circle geometry. In our last video lesson, we talked about the theorems of circle geometry from theorem 1 to theorem 5. But in today's video lesson, we are going to be taking theorem 6 to theorem 10. So if you are yet to watch our previous videos on circle geometry, please do well to watch the previous video so that you understand better. So we are going to begin from theorem 6 of circle geometry. What does theorem 6 talks about? Theorem 6 says the angle between a tangent. Do you know what a tangent is? A tangent is a line that touches the edge of a circle. For instance, if this is a circle like this, a tangent is that line that brushes the edge like this. This line is called a tangent. Why is it called a tangent? It is called a tangent because it touches the edge of a circle. Okay? The angle between a tangent and a chord. What is a chord? Very easy. Don't forget that a diameter is a line that passes through the center of a circle to touch both edges of the circle. But a chord, for instance, is a line that divides a circle into two unequal parts. If I have a circle like this line can be referred to as my chord as long as these two parts of the circle are not equal. Now, I said this is a tangent. A chord can be like this either. This is a chord. So there is a relationship between a tangent and a chord. Okay? They said the angle between a tangent and a chord, which is what you are seeing. This is a tangent and this is a chord. This is also a chord either. Are we together? The angle between a tangent and a chord through a point of contact is equal to the angle in the alternate segment. Wow. What does this one mean? Very easy. This is a tangent and this is a chord. If you watch very well, the tangent and the chord came together to form an angle here. And then there's an angle which is in the opposite segment. What is that angle? It is this one. So they are telling you that if this angle is labeled as A, this angle will also be labeled as A. Why? Because they are both equal to each other. Is that clear? Yeah. I drew two diagrams for you so that you can understand it better. So this angle and this angle, they are the same. Why? Because the angle between the tangent and the chord forms an angle which is equal to the angle in the alternate segment. This is it. Please, this is how to trace it. It is quite very easy. Whenever you see a tangent and a chord comes together, you should be able to know the angles in the alternate segment. Why did I say so? Take a look at this triangle. This is a triangle like this. Yeah. This is a triangle. There is an angle here. Don't forget that you usually draw an angle through an arc. This is an arc. And you watch very well that the triangle inside the circle have three angles. Okay? We have this angle, this one, and this one. How do I know the angles in the alternate segment? Very easy. See, this angle here, which is the angle between the chord and the tangent, is here, okay? And it touches this line. This line that it touches has two angles, which is the angle here and the angle here. Make sure you are not equating this angle to the angle to which the line, it touches the line, which is this and this. It is either equals to this one, which is the opposite side. Quite very cheap. For instance, if there's an angle here, either, maybe the chili stroke, and the angle is labeled as C, it will not be equal to this angle, no, because this arc touches this line, so it will be equal to the other angle which is here, labeled C. So the angle in the alternate segment are what? Equal. Take a look at this diagram. So you see that this angle and this angle, they are equal because this is a tangent, this is a chord, and it forms an angle which is equal to opposite of the word, alternate angles. Look at it on the board. If I have an angle here either, it will be equal to the angle that is here. That is theorem 7 of circle weighting and geometry. Let us go over, theorem 6. Let's go over theorem 7. Two tangents. You can draw two tangents to intersect outside the circle. Like if I stretch my two hands like this. Okay? This is a tangent. This is also another tangent. Please, I want you to know that if two tangents are drawn outside the cycle to intersect, the two tangents will be equal in length. Yes, they must be equal in length in order for them to intersect at a point which we label as waiting as B. Now let's go over to what the theorem says. Two tangents which are drawn from the same external point of a cycle are equal in length. Not only are they equal in length, there are also some other values that can be determined from here. Please take a look at this. Number one, we say A to B is equals to B to C, which is what we have as our word A. So take note, the lines are what? Equal. Now, there's also an angle that is here. Take a look at this angle, please. The angle here and the angle here, they are what? The same. If a line is drawn from the center of the cycle to touch the point of the intersection. So the angle OBA, there's an angle here also. Let's take double stroke, take another one here. This line that you see here is dividing the angle that is here into two equal halves, as long as the angle at the point of the intersection into two equal halves. So let's see what the other theorem says. OBA, which is OBA, which is this angle that is here, OBA, the angle here, is equals to OBC, see it, OBC. So the angle that is here is equal to the angle that is here. This angle we call this one we call this one. It's very easy. The other one, it said BOC, which is this angle that is here, is also equal to this angle, which is called BOA. They are equal to each other, yes. BOA. So BOC and BOA, they are equal to each other. One more thing you should know, the angle that is here is 90 degrees. The angle here. So the angle which a radius, see, and this line is called a what? A radius. The angle which a radius makes with a tangent is a what? A right angle. A radius and a tangent is what? A right angle. This must be noted. Let's go into the other theorems of circle geometry. Okay, now theorem 8 of circle geometry. Now let us look at theorem 8. Theorem 8 says that the angle between a tangent, I told you what a tangent is, a line that approaches the edge of a cycle, and a radius is 90 degrees. This is a radius, please. A radius is a line that is drawn from the center of a cycle to the edge of a cycle, as you can see on the board. So if I have a tangent and a radius, the angle formed between them is a what? A right angle. That is it. Theorem 9. The perpendicular line from the center of a cycle of a chord bisects the chord. Now, what's a perpendicular line? It's a line drawn at 90 degrees to a particular plane surface or line. Now, take a look at this particular line. This line is called a perpendicular line, okay? Now, this one is called a chord, AB. What they are saying here is this, is that this perpendicular line that originates from the center of a cycle to meet the chord bisects the chord into two equal halves. What does that mean? It means that if the length of the chord is 20 meters, it will now be 10 meters here, 10 meters here. So we can say that AM is equals to BM. That is to say, the length from A to M is the same with length of B to M. That is one. Number two, if this line is a perpendicular line, we could say that this is the height of the chord from the center of the cycle. Now, remember that this is radius and this is radius. If this is radius and this radius, remember that the radii of a circle, they are equal. And if that is, okay, it means that you have this length equals to this length. So we have a triangle where two of the sides are equal to each other. This type of triangle here now is called isosceles weighting triangle. And because it is an isosceles triangle, we can say that the base angle here, they are equal to each other. So let's be fast to say that angle OAB is equals to OBA. So we can say angle A is equals to what? Angle B. Please take note of that. Again, you can still discover that there is a right angle triangle that is formed at this place. Yes, a right angle triangle. So which you can determine the radius of this cycle or the height of the chord from the center of the cycle or the distance of one of the length of the circle using your Pythagoras word theorem. So by Pythagoras theorem, we have that the radius, which is r squared, is equals to the height here, which is h squared, plus the distance from here to here, bm squared. So this must be noted that when you have an isosceles triangle in the center of the cycle, such that you have a perpendicular bisector to bisect the chord, you can use Pythagoras theorem to determine any of the parts that is worth mixing. Please, this must be noted. Let's take the other theorem of circle geometry. Theorem 10 of this circle geometry talks about the intersection of a chord. I told you what a chord is, that a chord is a line that divides a circle into two unequal parts called segments. If the line passes through the center of the cycle, it will be called the diameter, otherwise it is called a chord. Is this line a chord? Yes, it is. Is this line a chord? Yes, it is. Because it divides the circle into two unequal halves. Class, let us look at the theorem that binds the intersection of two chords. Two chords can intersect outside the cycle, which we call outside the circle, as you can see here. Look at this chord and this one. They are meeting at the point outside the waiting cycle. Now look at this one also. These two chords are meeting at a point inside the cycle. This one is inside, this one is outside. Now what theorem governs or covers these two problems? If you come across them in your exam, please use this theorem to demystify. What is a theorem? Very easy. Now what do we have to do? We'll take this. From here to here is the full length of the chord called AC. As you can see on the board, A to C is the full length of the chord. It looks like the length that forms a triangle. Look at it, okay? Good. So we do AC times, now we have this small triangle here, which we call BC. Look at it very well. The full length AC to the short length BC. Take a look at it here. Equals to the same thing. The full length CE. You know we have to arrange it in alphabetical order. Don't do EC, do CE. Then to the short length, which we call what? CD. With this important formula, you will be able to solve what? The problem involving intersection of two chords outside the cycle. Now, what about the intersection of two chords into the cycle? Wow, it's quite very cheap. Just do this to this, that's this to this, UY times, you finish it, WY equals to do the same thing, XY times VY. So it's very easy. Half, 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 half. This is a theorem. So what I'm going to do in this lecture now, we are going to take like just three questions, WAEC, NECO, and post-UME. Let us do that quickly. Now let's solve this simple question from UME 1998, question number 3028. How do we solve this question? Take a look at the diagram on the board. You'll see that the theorems of circle geometry should be applied to solve this problem. Now, what did the question say? TQ is a tangent, which you all know, TQ, to a cycle. Okay, they gave us the cycle, and you see all the angles that are given in the diagram. The question says we should find, we should do what? We should find the angle YTR. That's what we are looking for. We are looking for the angle Y, this is Y, T, then R. We are looking for the entire angle that is in this place. How do we solve this question? Very easy. Now, take a look at this angle. Remember, this is a chord and this is a tangent. the angle which is formed by the intersection of a tangent and a chord is equal to the angle which is in the alternate segment. Don't forget that theorem. So if you watch very well, there's a triangle that is here. As you can see on the board, this is a triangle. Okay? If this is a triangle, there's an angle here. This angle and this angle, they are the same. You should know that. I told you. Okay? This angle and this one, this is the triangle we are looking at here, is the same. So what do we simply do? Well, this question is quite very cheap. We can say that angle TX arrow is equals to what? 40 degrees. What is our reason? Angles by the alternate segment. That's our reason. Okay? So if this angle is already 40, how do we get this angle that is here? Remember that in our former video lesson, I told you that the sum of two angles in a cyclic quadrilateral is supplementary. So in this quadrilateral that you are seeing, if this angle now is 40, the angle here and the angle here will sum up together to give us 180 degrees. Check our previous video on circle geometry for more details. So what do we say now? We are going to say that YT arrow, which is this angle here, plus 32 plus 40 is equals to 180. What is our reason? Sum of opposite cyclic quadrilateral. Yeah, sum of opposite cyclic quadrilateral sum up to be worth 180. So what do? We have YT arrow plus this will give us 72 degrees equals to 180. So YT arrow will give us 180 minus 72 if you collect like terms. So YT arrow will give us waiting at 108 degrees. The answer is what now? A. Let's take question number 2. Now, if you come across this question in circle geometry, how do you solve it? Very easy. Now, this question number 2. Let's quickly solve this question. Like I told you, the 10th theorem of circle geometry has to do with the intersection of two chords. As you can see, both of them are chords. Actually, the center of the circle is somewhere around here, so don't mind the diagram. Let's take this as a chord and take this as a chord. If they are both chords and then they are intersecting at a point outside the cycle, remember the formula I gave you. Wow, what is the formula? Very easy. From here to here, you have IG, okay, times what now? HG or GH equals to you. Now you see that from here to here, then here to do the same thing. E to G, that's EG or GE. Okay, EG times here to here, which is what? FG. That's what we have. So you have here to here times here to here equals to here to here times here to here. So it's very easy. Now let's solve it quickly. IG. You remember they told us that IG is 6 centimeters. So you have 6 times GH. Did they give us GH? GH. Okay. Two chords EF and R intersect at G when produced. If EG is this is it. Okay, we are probably looking for GH. So let's leave that. Let's leave that aside. Okay. You have 6 centimeters from I to G. Then we have GH. Okay. So let's leave it like GH. GH is unknown. Equals to EG. EG is from here to here. Did they give us EG in the question? Yes, it is 8 centimeters. Okay, times FG. Was FG given to us or GF? Yes, it is 3 centimeters. So you have what there? 3. So what do you have? You have 6 GH is equals to what? 24. If the Bible side are waiting 6. This cancel this. GH is equals to what? 4 centimeters. So the question wasn't complete. We are supposed to find GA. So the answer is what now? C. Last question. Now let's solve this question. The question, if you look at the diagram, you see that we have an isosceles triangle here. Why did I say so? Take a look at this double line, this double stroke. It signifies that the length here and the length here, they are words equal in values. Okay, so take note of that. It should be noted. Now the length here and the length here, they have equal value. So permit me to say that our xy is equals to our word yt. Take note, they are equal to each other. Now the questions ask us to calculate what? Calculate tzy. T, z, then y. We are looking for the angle which is in this place. That's what we are looking for. So how do we solve it? Very easy. Let's do this quickly. Remember that if a chord and a tangent comes in contact, an angle will be formed. The angle will be equal to the angle in the alternate word segment. Okay, so this is a chord. Remember, this is a chord and this is a tangent. Okay, now let's work with this. We have a triangle produced by that. See, I'm here. 9 be this. Are you seeing it now? Yes. So if here is 50, here will also be weighting at 50 degrees. So let's quickly jot it down to say that angle weighting at x, y, t. Okay, x, y, t is equals to 50 degrees. What is your reason? Angles by the alternate segment. Please take note of that. Alternate segment. Angles by the alternate segment. So guys, if here is 50 degrees, how do we get the angle here and the angle here? How do we get it? Remember that this is a triangle and these two angles are what? Equal. Permit me to label it as A and A. So A plus 50 will give us weighting at 180. So let's do that. A plus 50 is equals to 180. What is your reason? Sum of angles in a triangle. Please note it. A plus A will give us 2A plus 50 is equals to 180. 2A will give us 180 minus 50. Then you have 2A equals to what? 130. Divide both sides by weighting at 2. This cancel this. A is equals to 65 degrees. Now, so the angle here is 65 degrees. The angle here is 65 degrees. Remember, we are told to find this angle. Let's quickly do this, please. Let's get the angle that is in this place. Let's get that. This plus this will give us 180, which is some of the angles in a straight line. So let's do that. We have 50 plus 65 plus this angle. This angle is let's call it Q equals to 180 degrees. This will give us 115 plus Q equals to 180. So Q will give us 180 minus 115. So what would that give us? 180, 115. 180, 115. 5. This is 7. That will give us 65 degrees. Okay, so if you have 65 degrees, the angle here is what? 65 degrees. Remember that the angle here, this angle here is the same angle that is here because it is angle between a tangent and a chord. So take it, the angle outside a tangent and a chord is equal to the angle in the opposite segment. So the angle we are looking for, which is TZY, is equals to 65 degrees. The answer is what? B. We have come to the end of today's video lesson. If today is your first time for coming across my YouTube channel and you are a student preparing for WAEC, NECO, JAMB, Post-UTME, please do well to subscribe to this channel for more. And if you have any questions as regarding what we have considered so far, please send your answers to me or your question in the comment section. Thank you very much. I'll see you in our subsequent videos.